refresh your memory on how to factor binomials. What is the strategy? So factoring binomials. A binomial has two terms, in other words. And the strategy is this. Number one, I ask myself, is it in descending order? If it's not in descending order, please get used to it. You have to arrange it in descending order. It's a must. Step number two, I will ask myself if there is a greatest common factor, GCF, greatest common factor. You can put it in step two together. Step 2 and 3 can be together. And negative leading coefficient. They can be together. So if there is a greatest common factor, I pull it out. If there is a greatest common factor and a negative leading coefficient, I pull out negative and the greatest common factor. If there is no greatest common factor, but the leading coefficient is negative, then I only pull out the negative one. So this is a must from all terms. So the greatest common factor to both terms and the negative leading coefficient. If both exist, they have to be out in front of the polynomial, in front of binomial. So descending order, greatest common factor, negative leading coefficient. Of course, at this point in time, I ask myself, what is it? Because this question has three possibilities: binomial, trinomial, or polynomial. So the above steps are the same no matter what I factor, no matter what I'm given. If I'm given a binomial or trinomial or polynomial, it doesn't matter. I have to go through these steps. And once I ask myself and I identify that it's a binomial, then I continue with a strategy. So let's say it's a binomial, because that's all we know for now. Because it's a binomial, then I continue with special products. And as we remember from Tuesday, there are four special products here to remember. The first one is a squared minus b squared that we discussed last week, which is a plus b, a minus b. This is the difference of squares. And last week we went from right to left. Now we're going from left to right. The next special product is a squared plus b squared, which is not factorable. To be exact, I should write not factorable using integers. That's the correct answer. And then last time we looked at the sum of cubes and the difference of cubes. I think I lost you for a moment, or you lost me for a moment. I think I'm back. Okay, so this is the sum of cubes or the difference of cubes. And it factors into a binomial and a trinomial. If you remember this, you should not make a mistake, ever. Also, please remember, we always start with a sequence of signs. So that is always the best step to start with. Positive, positive, negative. We never talk about the last one. The last one is always positive. Now, if we have a difference of cubes, then the minus here, but plus here. Of course, the last one is always positive. We never even mention it. And the rest is easy. Once you identify the a and b, what I cube to get this, and what I cube to get this, the rest of the pattern is very easy. I square this, multiply them without the 2, that's a different formula, multiply them and put them in the middle. That's it. So once I identify the a and the b, the pattern here is very easy. I square the first, I square the last, I multiply them and put that in the middle. And this is it. Any questions so far? Trust me, students have difficulties with factoring forever. If you understand the strategy now and you practice with me, you will never ever have, you will never be sorry and you will never have problems with it ever again. Okay. So keeping all this in mind, now we're ready to practice. So I'm going to share the first document. This one. Okay. And we're going to start at the top where we have binomials. So here I have 6 examples. After we finish these 6 examples, we're going to go to the practice for binomials in Pearson and select more. And then continue with, maybe I should just completely finish the entire strategy and then go back to a mixture of questions. I think I'm going to do that. Okay. So I think we discussed the 4z. Did we or did we not? What was the previous year? Yes, we did. We did talk about the 4z squared minus 25 as being 2z plus 5, 2z minus 5. So we continue with the next one. And the next one was x to the 4th minus 81. Okay. So I'm given this binomial to factor. I go through the strategy. Is it in descending order? Yes, it is. Does it have a greatest common factor and or negative leading coefficient? No. There is no greatest common factor between of the terms x to the 4th and 81. So there is nothing I can pull out right away. Then I reach the question, which obviously at this point we only talked about binomials. So the answer is it's a binomial. So then I have to look at the special products. I always hope for a special product because the special products are easy. Once I understand the pattern, they're easy to factor. Okay, so first of all, it's a negative binomial with minus in between. It could be this, because it's a difference of squares, or it could be this, which is the difference of cubes. But there is nothing I can cube to get x to the 4th. It doesn't exist. So my only hope is the difference of squares. That's the thinking behind the strategy. I see negative. I can only think of the difference of squares or the difference of cubes. But there is no number that I can cube to get 81 and no term that I can cube to get x to the 4th. So therefore, it doesn't matter how you write it. You can write a plus b and a minus b. So I hope that this works. That's special product. So if that's the case, I have positive and negative. Always take care of the signs first, so you don't have to worry about the signs later. And or get confused. Is it plus? Is it minus? So it's the difference of squares. So plus and minus, or minus and plus, it doesn't matter, but they have to be opposites. And now I have to think. That's the reason, that's one of the reasons we study the exponential rules. What term do I square to get x to the 4th? What term do I square to get 81? So these have to be identical, one with plus, one with minus. So what term do we square to get x to the 4th? Again, that's why we studied special product. That's why we studied special products and especially exponential rules.
3.
So 3 squared is 9. It's not 81.
X squared.
Yes, the first one is x squared. I completely agree, because we know that x squared squared is x to the 4th. Excellent. Good. So now what term here do I square to get 81?
9.
Exactly. So we have 9 and we have 9. When we're asked to factor a polynomial, we're asked to completely factor, meaning now I have two factors. Which factors? X squared plus 9 and x squared minus 9. They are factors because they are connected by multiplication. This one is the sum of squares. So I cannot do anything here. This is done and carved in stone. But there is something I can do with this, because it turns out that I can continue applying the difference of squares to this second factor. So I'm going to do just that. So I will copy the x squared plus 9 because that factor cannot go away. So I have x squared plus 9. And if this indeed is the difference of squares, then I have to get ready two binomials. What are those two binomials? Can anyone give us? Of course, if it's a difference of squares, I should always prepare the sign first. Plus, minus, or minus, plus, it doesn't matter. And now I'm asking, say it again.
X and 3?
Exactly. X and 3, x and 3. Perfect. And this is completely factored. Do not go back to distribute. No. This was an effort to change it from a sum of two terms, in other words, from a binomial, to a product of three factors. Which three factors? X squared plus 9, x plus 3, and x minus 3. Why are these factors? Because they are multiplied. Why are these terms? Because they are added or subtracted. Any questions on this problem before we move on? Okay, we're moving on to x cubed plus 8. No, it's not the x cubed. It's y cubed plus 8. Doesn't matter. But it's y cubed plus 8. Okay. I go through the strategy. You make your life way more difficult if you do not go through these steps quickly. It only takes 5 seconds. It will help you throughout the entire process or strategy of factoring. Please always, never ever skip these steps. It will only take 5 seconds or less. Descending order, yes. Greatest common factor, no. Negative leading coefficient, no. What is it? It's a binomial. It took 6 seconds maybe. Good. Now I have to think of the special product, if there is one. So I see that the binomial has plus. So there are only two options for plus. Either the sum of squares, and I will say either not factorable or prime. I don't like this, but some books will use prime. In other words, not factorable, or the sum of cubes. So I have to identify if I square something to get 8, then I'll say, okay, it's a perfect sum of squares and it's not factorable. Or if I cube something to get 8 and I cube something to get y cubed. Because I have to make a decision. Is it a sum of squares or the sum of cubes? Which one is it?
Cubes?
Yes, it is a sum of cubes. Once we identify it is a sum of cubes, I have to prepare a binomial and a trinomial. Again, if you follow my lead here on this, you will never have difficulties. You'll see my calculus students, Calc 2 students that cannot factor. Good. So first, the sequence of signs, please. This is crucial. I have plus, I have plus, I have minus, and I have plus. That is the first step, so I don't, oh, is it the plus, is the minus, do I multiply, but I get minus, I get plus, what do I get? No, 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 no. Plus, plus, minus, or minus, minus, plus. And we never talk about the last one. It's useless. It's always positive. Good. So now I have to determine what term I cube to get this, and what term I cube to get this. because this pattern is very easy. I square, multiply. But I need to determine what term I cube to get y cubed, what term I cube to get 8. Please, can anyone help? Anybody, please?
Okay, so I don't know if I'm fully right or just right at all, but to get y cubed, did you do y3?
So can you repeat the question, Angela?
Okay, so for y cubed, do you just do y3 or y cubed, or is it like you're trying to add
When I
two?
cube y, I get y cubed. When I cube 2, I get 8. So that was the question. Maybe I wasn't phrasing it correctly. What term I cube to get y cubed is only y. What term I cube to get 8, it can only be 2. Is that better?
Yes.
Factoring is not easy. I will never say that it's easy. But if you, as I said, if you follow me and if you ask questions like you just did, if you say I need another problem and so on and so forth, or repeat or explain, you will always understand this and it will be done and over with. And you can move on to something else. The pattern is very easy. I square this, multiply them, done. So the difficult part is, first of all, identify what special product it is. Secondly, to identify the binomial, the terms in the binomial, and this is easy. Square, square, product. Is this better? It's only our second or third example. We're going to have plenty more. Okay, the next in line, -1/16 and plus x to the 4th. Please go through the steps. Descending order? No. No. I have to rearrange it. Greatest common factor? No. Negative leading coefficient? No. It's +1. What is it? It's a binomial. Okay? So now I reach the step in which I ask myself, okay, it's a binomial, but is it a special product or not? Because it's a difference, I can only look at 2 options. One option is the difference of squares, and the other option is the difference of cubes. Now we have to make a decision. Let's make a decision. Is it a difference of squares, or is it a difference of cubes? Because if you say a difference of squares, I have to come up with 2 binomials. But if you say the difference of cubes, I have to come up with a binomial and a trinomial. 2 different formulas, very different. Good. So let's identify whether this is a binomial, I'm sorry, the difference of squares or the difference of cubes. In other words, is there something I square to get to x to the 4th, or is there something cubed that I get x to the 4th?
Difference of squares.
Of course. There is nothing that we cube to get x to the 4th. Good. In that case, we have to prepare 2 binomials, one with plus, one with minus. Excellent. Good. So So, anybody, please?
X squared,
Yes, indeed.
1/4.
Indeed. How come? Because 1/4 squared, 1 squared is 1, 4 squared is 16. Excellent. And these are exact terms. The difference is the sign. Excellent. Thank you. Perfect. Now, this is a sum of squares, but this can be further factored, and we have to. So x squared plus 1/4. Again, the difference of squares, meaning a plus and a minus, and we're looking for two binomials. Very good. So, let's think. What do we square to get x squared? What do we square to get 1/4?
The x and 1/2.
That's it. X and 1/2, x and 1/2. And this is now carved in stone. Linear factor, quadratic factor, degree 2, degree 1, degree 1. That's why degree 2 times degree 1 times degree 1 is degree 4. Good. Going back. Very good. Thank you so much. Good. So the next one is 1/27 minus x to the third. Please do not skip